Cold open. The question today is not whether artificial intelligence is dangerous by itself. The better question is this: what happens when AI tooling becomes part of the path that builds, deploys, authenticates, routes, or observes production systems? Today's Daily Tech Hack Global Deep Dive is about that exact shift. NVD entries published or updated this week include critical or high-severity issues touching a command line AI workflow, an AI workflow platform, an MCP-related token validation path, and an AI gateway. None of that means every viewer is exposed. It does mean defenders should stop treating agents and copilots as side experiments once they reach CI, identity, secrets, cloud logs, or customer data. The central thesis is simple: agent-era security is still identity security, supply chain security, patch discipline, and blast radius control, but the speed of automation makes weak boundaries more costly. Here is the confirmed source picture. The lead item in this briefing is CVE 2026-12537, Google Gemini CLI and the Run Gemini CLI GitHub action. NVD lists it as critical with CVSS 10.0. The summary says, improper neutralization used in an OS command in the container launcher in Google Gemini CLI, versions prior to 0.39.1, and Run Gemini CLI GitHub action, versions prior to 0.1.22, on headless CI platforms allows an unprivileged attacker to achieve pre-sandbox host-level code execution a maliciously crafted .gemini/.env file. The safe takeaway is not to reproduce an attack path. The safe takeaway is that headless automation and developer tooling deserve the same review we give production servers. If a tool can run inside CI, read files, reach tokens, or influence deployment output, then a configuration file, dependency, action, or plugin can become more than a convenience feature. It becomes part of the trusted computing base. The timeline matters. Over the last several years, organizations moved from chat-based assistants to coding copilots, then to command line helpers, workflow agents, retrieval systems, and AI gateways that route requests to multiple model providers. In parallel, cloud teams adopted more automated observability and response. Microsoft's recent blog framing around agentic observability captures that direction. Operations teams are preparing for systems that act more autonomously and interact across wider software networks. That creates a productivity opportunity, but it also raises a security question: when the operator is partly software, who constrained the operator, who validated its inputs, and who can prove what it changed? Story 1, CVE 2026-12537, Google Gemini CLI and the Run Gemini CLI GitHub action. Confirmed facts from NVD and the linked advisory: improper neutralization used in an OS command in the container launcher in Google Gemini CLI, versions prior to 0.39.1, and Run Gemini CLI GitHub action, versions prior to 0.1.22, on headless CI platforms allows an unprivileged attacker to achieve pre-sandbox host-level code execution a maliciously crafted .gemini/.env file. Defensive meaning: teams using the affected versions should identify where the tool runs, especially in headless CI or automation, and move to the fixed releases listed by the official advisory. Review permissions on runners, environment files, repository secrets, and tokens. If an AI helper only needs narrow repository access, do not give it broad cloud privileges. If it only needs a test workspace, do not run it beside production deployment credentials. That is the difference between a tool bug and a business incident. Story 2, CVE 2026-56270, Flowise AI Workflow Tooling. NVD describes Flowise AI workflow tooling and says, Flowise before 3.1.0, versions 3.0.13 and earlier, contains a missing authentication vulnerability in the /API/v1/login method endpoint that allows unauthenticated users to retrieve an organization's complete SSO configuration, including OAuth client secrets in clear text, by providing an organization ID parameter. Remote attackers can send a GET request to harvest sensitive API credentials for Google, Microsoft/Azure, GitHub, and Auth0 integrations. This affects Flowise AI Cloud and self-hosted instances where the endpoint is exposed. This is an AI security story because workflow builders often connect to Google, Microsoft, GitHub, Auth0, vector stores, internal APIs, and business data. The core lesson is not exotic. It is exposure management. Know which endpoints are reachable, remove public access that is not needed, upgrade to fixed versions, and rotate credentials when a disclosure path may have exposed them. For security leaders, ask a basic inventory question: which low-code or AI workflow tools have OAuth secrets, service tokens, or access to internal data, and who owns their patch window? Story 3, CVE 2026-11718, Google API's MCP Toolbox Opaque Token Validation. The source summary says, an authentication bypass vulnerability exists in the generic opaque token validation path, validate opaque token, of Google API's/MCP Toolbox. When the toolbox validates an opaque token via an OAuth 2.0 introspection endpoint, RFC 7662, it decodes the response into an introspect RESP struct. However, the subsequent claim-checking logic, validate claims, evaluates the issuer condition as if a.issuer equals and ISS equals. If the external OAuth provider's introspection response omits the optional ISS issuer field completely, the variable ISS defaults to an empty string. This causes the conditional block to evaluate to false and be skipped silently. Consequently, the application accepts tokens issued by unauthorized or unintended third-party identity providers. MCP and tool calling ecosystems are important because they connect models or assistants with external capabilities. When token validation or issuer checking is not strict enough, the problem is not just a failed login check. The risk is that an automation layer may accept trust from the wrong identity provider or the wrong context. Defenders should verify issuer, audience, token type, scopes, and introspection behavior. They should also log rejected and accepted authentication flows in a way that incident responders can actually search later. Story 4, CVE 2026-49468, Light LLM AI Gateway. Confirmed source facts, Light LLM is a proxy server, AI gateway, to call LLM APIs in OpenAI, or native, format. Prior to 1.84.0, this vulnerability is fixed in 1.84.0. AI gateways and model proxies are becoming policy enforcement points. They decide which model receives a request, which key is used, what logging is applied, and sometimes which team pays the bill. That makes them security infrastructure. Treat gateways like API gateways, patch quickly, keep admin surfaces private, protect provider keys, test authorization boundaries, and monitor abnormal usage spikes. If an AI gateway is compromised, the impact may include data exposure, unexpected cost, or loss of control over prompts and responses. Story 5 broadens the lens, CVE 2026-27604, FOSS Billing API Role Handling. NVD Summary, FOSS Billing is a free, open-source billing and client management system. Starting in version 0.5.4 and prior to version 0.8.0, an authorization bypass in the API role handling allows unauthenticated access to privileged/API/system/*endpoints. Because system resolves to the cron admin identity, attackers can invoke admin API methods without valid credentials, session, or CSRF token. Version 0.8.0 patches the issue. Some workarounds are available. Block external access to /API/system/ at reverse proxy /WAF, restrict API access by trusted source IPs only, API.allowed_IPS, rotate all admin/client API tokens immediately, invalidate active sessions and reset high privilege credentials, and/or review API request logs for suspicious /API/system/ access and treat as potential incident. Even when a vulnerability is not labeled AI, it can still affect the same blast radius. Billing systems, proxies, databases, cloud clients, and identity services often sit next to the systems that agents use. A mature program should not split the world into AI risk and normal risk. It should ask where automation has privileges, where secrets live, and what happens if a nearby service is abused. Now the technical explanation at a safe level. Most of these issues live around boundaries. A command line reads local configuration, an endpoint returns secrets, a token validation path accepts or rejects an issuer, a gateway routes model calls, an API role maps to privileged actions. Boundaries fail when assumptions are too broad. A local file is assumed safe because it lives in the repository. An introspection response is assumed complete because a provider usually includes a field. A workflow endpoint is assumed private because admins normally use it. A gateway is assumed internal because only developers know the URL. Attackers and accidental exposures both exploit those assumptions. Defenders should replace assumptions with controls, explicit allow lists, version pinning, least privilege, network restrictions, secret scanning, strong issuer validation, and audit logs. The payoff for the middle of the video is this: if you do only one thing after watching, map AI tooling to privileges. Make a short table with each copilot, CLI, gateway, agent, workflow builder, and model proxy. Add where it runs, what credentials it can read, what network it can reach, what data it logs, who can change it, and how fast you can patch it. That table will reveal more risk than a long debate about whether AI is good or bad. It turns a vague concern into engineering work. For developers, the defensive playbook starts in the repository. Pin trusted actions and dependencies where possible. Keep CI runner permissions narrow. Avoid putting production cloud credentials in jobs that build untrusted branches. Treat dot files, environment files, prompt files, and tool configuration as code that can change behavior. Review what an agent can read before letting it summarize private data. Use separate test credentials for experimentation. If an advisory mentions headless CI, assume the highest risk is a runner with too much access. For platform teams, the playbook is governance without blocking useful adoption. Put AI gateways behind normal access controls. Centralize provider keys instead of spreading them across laptops and random automation jobs. Require owners for workflow platforms and model proxies. Monitor token use, model spending, unusual prompt volume, and new integrations. Keep logs long enough to investigate. Add an emergency procedure for rotating AI provider keys and OAuth clients. If a tool integrates with GitHub, Google, Microsoft, or Auth0, its secret inventory matters. For executives and risk owners, the business question is consequence. Could a vulnerable AI or developer tool reach customer data? Could it change builds? Could it expose cloud secrets? Could it run commands inside CI? Could it generate a large unexpected bill? Could it bypass the approval gates that normally keep production safe? Those answers decide urgency. A critical CVE on an isolated lab system is not the same as a high-severity bug on a public workflow builder holding OAuth client secrets. What should viewers watch next? First, whether any of these CVEs are added to CISA's known exploited vulnerabilities catalog. Today's collected candidates were not marked as known exploited in the local CISA KEV check. Second, whether vendors publish clearer exploitability, affected versions, or compensating controls. Third, whether organizations discover exposed AI workflow endpoints during their own scans. Fourth, whether agentic operations tools add stronger default permission boundaries. The direction is clear: AI is becoming infrastructure, and infrastructure needs boring controls that work under pressure. Bottom line. Do not panic because the word AI appears in an advisory. Do not ignore it either. The practical answer is to patch the affected products, narrow permissions, rotate exposed secrets, verify identity checks, and treat agents, gateways, and copilots as production components once they touch production paths. The teams that win will not be the teams with the most automation. They will be the teams that can explain what their automation can do, prove who it trusts, and limit damage when a component fails.